Now we will see problem number 3. GSHS is equal to k into bracket s plus 5 divided by s square plus 4s plus 20. We have to draw the root locus of this function. Therefore, step number 1, we determine number of poles and zeros. Therefore, for poles, always remember poles are there in the denominator. Therefore, what is the equation in the denominator? S square plus 4s plus 20 is equal to 0. Therefore, s is, you have to determine roots of this equation. Therefore, s is equal to minus b plus minus b square minus 4ac divided by 2a, which is equal to minus 4 plus minus square root of 16 minus 4 into 1 into 20 divided by 2 into 1. Therefore, s is equal to minus 4 plus minus square root of minus 64 divided by 2. Therefore, s is equal to minus 4 plus minus 8j divided by 2. Therefore, s is equal to minus 2 plus 4j plus minus 4j. That is, s is equal to minus 2 plus 4j, that is one pole, and s is equal to minus 2 minus 4j, that is second pole. Therefore, number of poles p is equal to 2. Now, number of zeros. See that how many s terms are there in the denominator. Only a one s term, that is s plus 5 is equal to 0. Therefore, s is equal to minus 5 is the only 0. Therefore, z is equal to 1. Therefore, number of branches going to infinity n is equal to p minus z, which is equal to 2 minus 1 is equal to 1. Therefore, number of branches of the root locus n is equal to 1. Now, we will find out angle of asymptotes. Or first of all, we will find out centroid, and then we will go for angle of asymptote. Then step 2, centroid and angle of asymptotes. We have combined these two steps here. Sigma is equal to, centroid sigma is equal to summation of real parts of poles minus summation of real parts of zeros divided by p minus z, which is equal to, now what are our poles? Minus 2 plus 4j and minus 2 minus 4j. This 4j term is imaginary term and minus 2 is real term. Therefore, only real values we have to consider. And what is zeros? S is equal to minus 5. Therefore, which is equal to minus 2 minus 2 minus of minus 5 divided by 2 minus 1. Therefore, sigma is equal to minus 4 plus 5 divided by 1, which is equal to 1. Now, as number of branches n is equal to 1, we have only one angle of asymptote. Therefore, we have to take only one value of q, that is q is equal to 0. Therefore, theta is equal to 2q plus 1 into 180 degree divided by p minus z. Substitute the value. Therefore, theta 1 is equal to 2 into 0 plus 1 into 180 degree divided by 2 minus 1. Therefore, theta 1 is equal to 180 degree. Now, we will determine breakaway point. The characteristic equation is 1 plus GHHS is equal to 0. Therefore, substitute value of GHHS. Therefore, 1 plus k into bracket s plus 5 divided by s square plus 4s plus 20, which is equal to 0. Therefore, s square plus 4s plus 20 plus k into bracket s plus 5 is equal to 0. Therefore, k is equal to minus of s square plus 4s plus 20 divided by s plus 5. Now, differentiate this k with respect to s, equate it to 0. Therefore, dk by ds is equal to minus of 2s plus 4 plus 0 into s plus 5 minus of into bracket minus of s square plus 4s plus 20 into 1 plus 0 divided by s plus 5 bracket square. Equate it to 0, so that this s plus 5 square will go here and it will become 0. Therefore, minus of into bracket 2s square plus 10s, multiply these two brackets, minus of 2s square plus 10s plus 4s plus 20 bracket complete plus s square plus 4s plus 20 is equal to 0. Therefore, by simplification, minus 2s square minus 14s minus 20 plus s square plus 4s plus 20 is equal to 0. Therefore minus s square minus 10s is equal to 0. Therefore s square plus 10s is equal to 0. Therefore s square is equal to minus 10s. Therefore s will go, and therefore we will get value of s is equal to minus 10. Put s is equal to minus 10. Now this is the breakaway point. Breakaway point always exists in the root locus region. Always remember. Therefore, whether in our root locus region, where is our root locus region? Root locus region. What are the poles? First of all, we will see the poles and zeros. At s is equal to minus 5, 1 0 is there. Therefore, this is 0. And what are our poles? Minus 2 plus 4j and minus 2 minus 4j. Therefore, here between minus 5 towards right side of minus 5 or towards right side of this minus 2 plus 4j and minus 2 minus 4j, no poles and zeros are there. Therefore, p plus z is equal to 0. Therefore, between minus 2 and 0, no root locus region is there. Again, same case is, consider this s is equal to minus 5. Towards right side of these, two poles are there. Therefore, addition of p plus z is equal to even number, that is p is equal to 2 and z is equal to 0. Therefore, 2 plus 0 is equal to 2, even number. That's why no root locus region is there between 0 to minus 5, and beyond minus 5 root locus region exists. Therefore, minus 5 to minus infinity root locus region is there, and we are having s is equal to minus 10. Therefore, s is equal to minus 10 is the valid breakaway point. And centroid, we have got sigma is equal to 1. Locate that centroid. Now, intersection with imaginary axis. Next step, the characteristic equation is 1 plus GHHS is equal to 0. Therefore, substitute the value. We are getting s square plus 4s plus 20 plus ks plus 5k is equal to 0. Therefore, s square plus 4 plus k into s plus 20 plus 5k is equal to 0. By Routh's array, s square, s raised to 1, s raised to 0, 1, and here 20 plus 5k, and here 4 plus k 0. Therefore, by cross multiplication and dividing by 4 plus k, we are getting value in front of s raised to 0 as 5k. Therefore, as 4 plus k is equal to 0, that is k is equal to minus 4. Therefore, no intersection with imaginary axis, since no complex roots are there. If complex or imaginary value will be there, include which is multiplied by j, then it will intersect with imaginary axis. Since value of k is real value, therefore no intersection with imaginary axis. Therefore, angle of departure, as poles are complex, there is angle of departure. Now, therefore, phi p1 is equal to 90 degree. This is minus 2 plus 4j and minus 2 minus 4j. This is phi p1. This total angle is there. Therefore, tan inverse of 4 by 3 phi z1. Sorry, phi z1 now. Join this minus 5 with this first pole, minus 2 plus 4j. Therefore, what is this angle? Tan inverse of this height. What is this height? 4 plus 4. What is this length? Plus 3. Therefore, tan inverse of 4 by 3. Therefore, phi z1 is equal to 53.30 degree. Therefore, total angle phi is equal to phi p, summation of phi p minus summation of phi z. Therefore, summation of which is equal to phi is equal to 90 degree minus 53.14 degree. Therefore, phi is equal to 36.87 degree. Therefore, angle of departure at minus 2 plus 4j is phi d is equal to 180 degree minus phi, which is equal to 180 degree minus 36.87. Therefore, phi d is equal to plus 143.13 degree at minus 2 plus 4j, and phi d is equal to minus 143.13 degree at minus 2 minus 4j. Now, how to draw root locus? imaginary axis, y-axis, real axis, x-axis. Locate the values 0, minus 1, minus 0, this minus 2 plus 4j, this first pole, minus 2 minus 4j, this is second pole, and this is 1 0 is there at minus 5, s is equal to minus 5. This is the breakaway point at 10 degree. Now first angle of departure we have to plot at first pole, that is plus 143.17, therefore draw angle of plus 143 degree. Here at the second pole, that is minus 2 minus 4j, draw angle of minus 143. Now root locus always, and this is the breakaway point, therefore our root locus will start from this pole, it will make tangential, it will touch this angle of asymptote, angle of asymptote is 180 degree only, it will touch this angle of departure tangentially, and it will move like this, it will enter the real axis at s is equal to minus 10, again it will leave the real axis and it will move like this, and again from this also 140 minus 143 tangential curve will be there, like this your root locus is there. Thank you very much. This is the centroid, sigma is equal to 1.